Welcome to my channel Coding Society. We're diving into a fundamental concept that every programmer needs to know: data structures. Let's start. First data structure we're going to talk about is array. Think arrays as a school lockers. Each lockers has a fixed position, and you can quickly go any one of them just by knowing its number. In array, all elements are placed side by side in memory. That's because each element has specific index. Retrieving a value is extremely fast, and you can go directly its position without searching. However, if the array is already full and you want to add a new element, that can be tricky. 'Cause you can't squeeze another item, array has a fixed size. Next data structure we're going to talking about is linked list. Think of a linked list like a train. Each CA is connected to the next one. To get to a different car, you can't simply teleport there. You must begin at the front and navigate through each car until you locate the one you need. In a linked list, individual elements are kept in different nodes, and each node contain a value and a pointer to the next node in the sequence. This makes linked list more flexible, as you can easily add or remove the element without worry about the sifting. However, accessing element is time-taking as we have go through by every element from start. The next data structure we're going to discuss about is stack. This is a simple structure that follows last in first out principle. Means last element added is the first element to be removed. Just like 3-layer chocolate cake, as we cannot eat the second layer until we eat the first one. Each element is arranged in a one on top of another order. Unlike arrays, however, you can only access or modify elements from the top of the stack. This makes adding and removing items very fast because there's no shifting involved. The next data structure is queues. Unlike in stack, here the first in first out principle is used. In FIFO system, items are processed in the order they arrive. The earliest added item is the first to be removed, and this process continues till last item. Imagine you're in a line at a store. The first person to arrive is the first to be served, and newcomers join at the end, waiting their turn. This first come, first served approach exemplifies the first in, first out principle, ensuring fairness by processing items in the order they arrive. Now we are going to talk about is the HashMap. A HashMap is like a school locker system. Each student has a unique locker number. Instead of searching every locker, you go directly to the assigned number. Locker 4 for John, locker 5 for Harry. This direct access exemplifies the efficiency of HashMaps. A HashMap stores the data using key, value, pair. Where key is run through a hash function that determines where the value should be stored. An example of a hash function could be the length of a string. John's name, for example, is 4 characters long, so he's in position 4. Harry is in position 5. Her name is 5 characters long. If too many items has to the same mailbox, which we call a hash collision. For instance, if new student Jenny joins, which also have 5 ladders, we just can't put her in position 5. So, we need to have a hash collision resolution, which could be a linkless chaining from the HashMap position. Or it could be linear probing where you find the next available position. Either way, this is only real downside to HashMap. The next data structure is heap or priority queue. Think heap like a pyramid of stone, where the smallest one is always on top. You don't randomly grab a stone from the middle, you always take box from the top. In heaps, the top element must always be present. If any elements are removed from within the structure, another element must be moved to the top to keep the structure intact. Also, there are 2 types of heaps. First is the min heap, where every parent is smaller than its children and the top element is smallest. Second is max heap, where the top element is largest, and every parent is larger than children.